What's that? Say your answer again. Thank you. So, what do you think that might be? Sorry? Root 5. So it's the same thing with multiplication when you do division. You just divide the numbers inside the radical, and there's a radical over the answer. Okay? So, if we have, make sure I got the right letters here. I have some radical with some index, and there could be a number in front. Okay, it could be a mixed radical. And I divide it by another radical with the same index. That's just the same as m divided by n. You divide the numbers in front. And then you divide the numbers inside each radical to a single radical. Nope. Yes, you were writing it. Right, but now you can write this. You can only divide radicals with the same index. That means they both have to be square roots, or they both have to be cube roots. You can't mix roots. Okay. When we divide radicals that have variables in them, we always want to make sure restrictions are stated. But I'm really not going to worry about these. I'll do one that contains variables. And a radical is in its simplest form. This is actually really important. Okay. Make sure I phrase this right. If it's a fraction, the denominator does not have a radical. Does not have a radical. It's what we would call a rational number. Oh, sorry, the denominator does not have a radical. Now some, like that root 40 divided by root 8, the answer, well, it wasn't a fraction, so you didn't have to worry about it. But sometimes when you do division, actually many times when you do division, there could be a fraction in your answer. Okay? But let's just look at a couple of examples to start. What do you think 4 root 51 divided 2 root 3 would be? Divide the numbers in front to get 2, 4 divided by 2. Root. $17, I heard. That's correct. And you can't simplify that, so you're done. How about this next one? Root 12. You tell me if that's it. What's that? We can break it down further to root 4 times root 3, which gives us 2 root 3. Remember, it's kind of like fractions. Whenever you did operations with fractions, you always want to make sure your answers are reduced. With radicals, you always want to make sure they're simplified. Okay, this next one. What's negative 8 divide 12? I told you how to divide with these things. I told you for the last couple of years. If it doesn't divide cleanly, leave it as a fraction. So negative 8 divide 12 is negative 8 twelfths. Just make sure it's reduced. So we get negative 2 over 3. We're going to times that by root 18 divide root 9. Or root 18 divide root 2. Root 9. Remember, those are getting multiplied. Can I go further? Yeah, isn't the square root of 9 3? So isn't this the same as negative 2/3 times 3? Or 3 over 1? What's that? Cancel the 3's. And you get negative 2 over 1, which is just negative 2. So remember, sometimes you can simplify the radicals, sometimes you can take them exactly. Don't always assume there's a highest perfect square if you're trying to simplify. Sometimes you can do it exactly. Okay, now this is one of those ones where I'm not going to assess you on it, but let's just, it's pretty straightforward to do this one. What would you get when you divided the two? Well, what's 24 divided 3? Root 8. What's x squared divide x? X. Good. What can I do with this? Bless you. When we have numbers and variables, what did we do to simplify? Split. So root 8 times root x. Can I simplify root 8? Yeah, root 4 times root 2. I can't simplify root x. There's no highest perfect square. Highest perfect squares are exponents of 2, 4, 6, 8. There's not enough. This gives me 2. And what can I do with the root 2 times root x? Make a single radical, multiply them together. Excellent. All done. Okay. Good practice, but like I said, I'm not going to assess you on ones like this, where there's variables involved. I could give you one like this to start with and ask you to simplify, and you should know what to do. Okay, so it seems pretty straightforward, except when we encounter a question like this, and I'm going to save this for later. But what's 30 divide root 5? Can I divide them? Why not? They're not. What do you mean? Yeah, they're not both square roots. They're not both radicals. Excellent. You can't do it. Okay. But the answer is not x. Okay. But it said on the first page that our final answers, if they were in fractions, there can never be a radical in the denominator. So I can't leave it like this. I have got to make, well, you're kind of on the right track. I have got to make root 5 into a non-radical. What could I do to root 5? Anything you want. No, not, you have to do some mathematical operation to it. What could I do to it to make it a non-radical? Could I add something? Could I subtract something? Could I multiply something? Could I divide something?
Let's divide.
Make it root 25? How did you do that? Times it by, yeah. If you times it by root 5, you're going to get root 25, which is 5. But you can't just multiply the bottom by root 5. Otherwise, you're going to change the whole number. Whatever you do to the bottom, you got to do to the top. So you got to multiply the top and bottom by root 5. When you do that, you're going to get 30 root 5 up top. And on the bottom, you're going to get root 5 times root 5, which is root 25, which is just plain old 5. Done, right? No. You guys said no. So what do I need to do?
I feel like you need to get 30 by 5.
Oh!
Oh, that's all.
30 divided by 5 is the same as 6, and then you still got to times root 5.
Yeah. Okay.
You're good.
That's it.
That's it.
That's it.
What would you do? Okay, you can't divide here. Can't divide cleanly. So you're actually going, when you can't divide cleanly, you're actually going to have to multiply to divide. I know it sounds a little crazy. What would you multiply the top and bottom of this one by? Not root 3. You want to make the denominator root 7, root 7. What do you end up with? Root 21 over root 49, which is 7. What do you mean, can that be done? You can't divide these two any further. But remember, your answer can't have a radical in the denominator. This doesn't have a radical in the denominator, so I'm done.
Oh, in the denominator. Oh.
We're going to do C and D, and then we're going to leave these ones. So you can take those ones. I'm not going to worry about those ones. Okay. But one like C, you should be familiar with how to do. Okay, what can I multiply by? I can't divide cleanly. I can't divide root 2 divide root 6. So I'm going to actually have to divide by multiplying. What do I multiply the top and bottom by?
But you have to do it all at once, right?
Yes.
That means you need to root 6.
Okay, so good question. Do I multiply by 2 root 6, which would actually work? Or can I just multiply by root 6? Multiplying by just root 6, won't that still get rid of the radical?
Yeah.
So I don't have to multiply by 2 root 6. It would still work if you did, but it would make it more complicated. So only the radical that you see in the denominator. So what's 5 root 2 times root 6? 5 root 12, good. And what's 2 root 6 times root 6? 2 root 36. But what's root 36? And there's a times 2. So I end up with 5 root 12 over 2. Done? No. Because we can simplify the root 12. That can break down to root 4 times root 3. Which means it becomes 5 times 2 root 3. Which means it becomes 10 root 3. Yeah. Done? No, because I can actually divide the two fractions by reducing them. 5 root 3 over 6. Yeah, that one involves quite a few steps. There could be.
There's gonna be.
That means yes.
It's gonna be worthless.
Yeah, big mark question.
Said my piece. What would you do with this one? Times top and bottom by root y. And 3 times root y is just 3 root y. What's root y times root y? Which is, what's the square root of y squared? Just plain old y. And there's no, I can't go any further. We're going to stop there. Because, oh, sorry. I want to fill this in. When we can't divide radicals cleanly, we must, what's called, okay, this is the phrase that's used, what we just did in all these questions. Rationalize the denominator. Or make the denominator into a non-radical by multiplying. And what do you multiply by? It depends what radical is in the denominator in the original. So if you see a root 5 in the original denominator, you're going to multiply the top and bottom by root 5. You see a root 11 in the denominator, you're going to multiply the top and bottom by root 11. Unless it's one of those questions where you can divide it cleanly like we did on the first page. Okay? So what I would like you to do for Wednesday, and then we'll finish this on Wednesday, is like I said, you don't have to do 1D, but I'd like you to do 1, 2, 6, and 7. 1, 2, 6, and 7. Mm-hmm. Yes, please.
There's not a lot left. He said, I poured it out.
Sure, nice.
Watch the.
No, I'm not gonna watch.
What?
Stop bumping my desk. Get out of here.
Yeah. No.
Where? Are you guys caught up?
Yeah.
What does pretty much mean? You don't actually know. Are you caught up?
My sister are full, except they're probably missed.
Okay, go ahead.
Thank you.
I'll probably be there Friday.
That's popcorn on my desk. Yeah. Drop it.
Maybe we could actually do a couple of questions.
What?
Maybe we could actually do a couple of questions. That would be right now, yes.
Oh, yeah. Right? Or here. Or what?
Yeah, exactly. While you have the chance to ask. Lauren, go sit down, please.
I didn't even have to get it. I got it for free. Oh my goodness. Okay, let's do this.
No. Hey, sorry, let me just.
So I was gonna ask how you knew this was negative.
Okay, so when we use a right triangle in the coordinate grid, the sides will be negative depending on what quadrant it is. The hypotenuse is always going to be positive. Okay, but because I'm in quadrant 3, it's -3 here because I'm going to the left on the x-axis. And because I'm going down on the y-axis, this side is also going to be negative. So when I take the square root, it's not the positive one, it has to be the negative one because it's in quadrant 3.
So that means this is quadrant 1, quadrant 2.
Correct.
Oh,
Yes.
So then this is because this is.
Yes.
Yeah.
Yeah. What? I don't have any more. Yeah, it's gone. I'm serious. It's gone. Go sit down. Go sit down. Not familiar with anybody named Lewis. You seriously can't pronounce that name?
You ever heard the female named Lois?
Wow. Her name is Lois.
You know,
Other side of the street.
you know you two, somewhere out there are a couple of trees working very hard to produce oxygen for you two to breathe. I think you two should go.
Oh, we got it, we got it.
Why?
Can we close? Go to the next one.
Yeah.
Will it make it